Algebra benchmark 8.3, writing quadratic rules. This is kind of a tedious benchmark. There's two problems here. We need to come up with the zeros first, the x-intercepts. It's hard to read the graph probably here. This point right here is 8 over, so it's 8, 0. And the point over here, 1, 2, 3, 4, 5, negative 6, 0. And our intercept down here, which we'll use later on, is at 12, so 0, negative 12. That should help you do the problem. Now first we start with those intercepts, and thinking of them as zeros, we want to write the opposite of them, x plus 6 and x minus 8 to start the problem. And just say y equals that. Multiply it out. We don't have to, but this is the way that I think is easier. So minus 8x plus 6x minus 48. Combine the middle terms, we have x squared minus 2x minus 48. Now I'm going to keep drilling home that little shortcut thing here with the smiley face. Let's see if I can do this. I'll have to rewrite it probably. So I have x plus 6, x minus 8. And I'm just going to go, the first two multiplied is x squared. And then I'm thinking in my head, this smiley face here, I'm going to put it upside down so I have space, but I have 6x and negative 8x. 6x and negative 8x is negative 2x. So in one step I can take care of that. And then 8 times 6 is 48 with the minus. I think that's just quicker. At this step now, we need to find, that we have an infinite number of parabolas that go through these two dots. Okay. And that's all we've found so far, is that we have found the intercepts, some equation for the intercepts. We need to find which specific parabola fits this criteria here. So we're going to put an a in front of this. And figure out what a is to specify like the width basically of our parabola, how big our parabola is. And the way we're going to do that, it's kind of like when we find our y equals mx plus b and we plug in a point for x and y and we solve for b. We're going to do the same thing here with a. We'll take any point that's on the graph. This point here will work. Anything that's on a lattice point, it's easy to see. We could use any of those points. This is always the easiest one though. The y-intercept, where it's 0, negative 12, because one of our values is 0. So I'm going to plug in the 0, negative 12 in for x and y. So y is negative 12. A, 0 squared minus 2 times 0 minus 48. Okay. Now all this 0 stuff cancels. That's what's nice about it. So we end up with just negative 48 here. And this is multiplying. So don't add 48 right now. We have to divide by 48, the negative 48. If you look at this fraction, it's just 1/4. So I'll take that answer, take that fourth and plug it in for a, right there. So 1/4 times all that stuff. And this is basically your answer. I just want it simplified form, so distribute and put it through, and then we're finished. So 1/4 x squared minus, now this is 2 times 1/4, which is going to be 2/4. Just put that over 1, don't want to make it 2/8. So 2/4, then reduce it to 1/2. So twice a fourth is 1/2 x, and then a fourth of 48 is 12. Or 48 times 1/4. And there's our final answer. Circle it, and go on to the next problem. Our next problem is from a table, and we're going to do the same thing, same process, but we don't have the graph to pick the points, we just have to use our table. With our negative 2, 0 here, if you think about a graph, negative 2, 0, there's one of our x-intercepts. 0, 5 is our y-intercept. We're going to use that later to plug the point in. But we don't have the other x-intercept. We need to find it. So look at our table, look for patterns. I happen to see that the two 6's here look like they're toward the middle of our parabola, and then the 5 and the 5 reflect on each other here. So the middle of our parabola, or the vertex, is going to be in here. So I can just work my way out. I'll just look at the top of the graph. Everything goes up by 1. It's kind of nice. So then I'm just going to go 5 and just mirror the 5. I have 6, 6, so 5, 5, so 3 is next, and then 0 is next. So I just found my other x-intercept. So there's my x-intercept. So then I'm going to take that and write, using the negative 2, 0, and our 5, 0, I'm going to write x plus 2, the opposites, and the x minus 5 to come up with our equation. Multiply that out. X times x is x squared. Smiley face, we have a 2x and a negative 5x. So plus negative 3x. And then minus 10. We're good. We got the intercepts. Now we just need the specific parabola that fits through there. So let's put an a in front of there, just like before. And then plug in a point. Now again, this point I think is going to be the easiest, but any of the points in the chart will work, except the, don't use these points. Don't use the 5, 0 and the negative 2, 0. But use any of the other points and plug them in. I'm going to use 0, 5. So 5 equals a times, now 0 squared is 0. Negative 3 times 0 is 0. So I'm just going to end up with a negative 10 here. And it's multiplying again, so divide to solve. So a is negative 1/2. Take that negative 1/2 and plug it back in for a, basically right there. So y equals a, which is our negative 1/2, times x squared minus 3x minus 10. And again, distribute through, and then we're finally done. Now here we have a negative times a negative, so it's plus, and then a half times 3. I'm just going to leave it as 3 halves. If you want to put 1.5x, that's fine. And then negative times negative again is a plus, and half of 10, or 10 times a half, is 5. Okay.